In this video, we're going to talk about how to determine x-intercepts analytically. Okay, so I'm going to give you a quadratic equation or quadratic function here. I've got y equals 3x squared plus x minus 10. Now, we know how to graph that parabola, hopefully. You find your vertex, you find your axis-symmetry, then your vertex, your slope pattern, and do all of that. But our goal in this problem is to find the x-intercepts. Let's find the x-intercepts. Now remember, to find x-intercepts on a graph, right? So we're going to have some sort of parabola. I don't know what this parabola exactly looks like, but let's say it looks something like this. That's my parabola. My x-intercepts are here and here. It's where it crosses the x-axis. Think about what these coordinates could be. I'm just going to make some up right now. I don't know if these are correct or not. I doubt they are. But let's say that this coordinate here is 2, 0, and this coordinate here is 5, 0. Okay? What are we saying here? That coordinate is right 2 and up or down 0. Right 5, up or down 0. What do x-intercepts, all x-intercepts have in common? If I have a parabola that opens down like this coordinate and this coordinate, what do they all have in common? No matter what the x value is, the y value will be 0. Anytime a function crosses through the x-axis, the y value is 0. So let's go ahead and justify or provide a reason for what we're doing here. The x-intercepts occur when y equals 0, okay? So that's what we're trying to do. That's what we're trying to figure out. Well, how do I do that? When y equals 0, let's just plug 0 into y here. So we end up with 0 equals 3x squared plus x minus 10. There is my equation. Now I just need to solve this, okay? Now, because I have an a value, a b value, and a c value, I have two options. I could either use the factoring method or the quadratic formula. Now, I'm going to go through the factoring method here. The quadratic formula I'll do in a different video. But factoring, you should always try factoring first, because you're going to be using factoring a lot in future math classes, okay? So remember we look for a GCF. The GCF here is 1. So we just jump to our quadratic factoring. A times C is negative 30, and on the bottom is 1. The values at work here are going to be 6 and 5, a positive 6 and a negative 5, because positive 6 plus negative 5 is positive 1, and positive 6 times negative 5 is negative 30. Then we expand. We've done plenty of factoring here, so I'm not going to spend a long time on this component of it. Then we're going to group. So the GCF there is 3x times x plus 2. The GCF in this case is going to be a negative 5, and then left over would be x plus 2. Oops, x plus 2. And then our factors will then be 3x minus 5 and x plus 2. Now remember, we just factored this expression on the right-hand side. It is still equal to 0 at the end, okay? Now here's the crux of solving by factoring. We've got it factored. Our next step is to say, okay, if these two terms multiply, that's what we're doing here, to 0, that tells us that one of these two terms has to be 0. You can't have two numbers and one of them not be 0, because you wouldn't get 0 when you multiply. So what we can do with that is we can say, well, if one of these terms has to be 0, let's set one of them equal to 0. So we'll say 0 equals 3x minus 5. In this one, we'll say 0 equals x plus 2. And then we'll solve each one of these. So here we'll add 5 to both sides. And so we end up with 5 equals 3x. And then we'll divide by 3, and we end up with x equals 5/3. Now we can put that into a decimal or a mixed fraction, but I'm going to leave it like that. Here we're going to subtract 2 from both sides, and we end up with x equals negative 2. So our solutions, I'm going to go and write this down. Our solutions to this equation, to 0 equals 3x squared plus x minus 10, the solutions are x equals 5/3 and x equals negative 2. But that's not our answer here, because I wanted x-intercepts. Remember, when I graphed the parabola, the x-intercepts are written as coordinates. So what are those coordinates? Well, we know the x values, but remember, we also know the y values. So our coordinates are going to be 5/3 comma 0, and negative 2, comma 0. These are the x-intercepts to my parabola. Now, just going back to the zero product property real fast. What I can do to check to make sure this makes sense is I could take the x values that I get out, x equals negative 2, and plug them back into this equation just to see if it makes sense. If I plug in negative 2, I'm going to square it. So negative 2 squared is 4. Then times 3 is 12. And plug in negative 2 there. So I got 12 minus 2 is 10. And then minus another 10, we get 0. So in fact, negative 2 worked to make that equation work. If I plug in 5/3 here, well, that's going to be an interesting one. 5/3 squared is 25 over 9. And then multiply it by 3, I get 25 over 3. And then add 5 over 3. So 25 over 3 plus 5 over 3 is 30 over 3. And 30 over 3 is 10. 10 minus 10 is 0. So you can see that both of these solutions work for this equation. But again, I wasn't looking for solutions. I was looking for x-intercepts. All right, this should help you solve number 4 on your Unit 5 test.